So this next video will be covering Chapter 4, which is on apportionment and voting. So in terms of, you have in terms of first what is called the Hamilton plan. And so you have what's called the standard divisor. And that is given by the total population divided by the number of representatives. So let's go through an example as to how that would work. And so we have this one. So we have in terms of the state and then the population of each part. And so we have Apis, Libra, Draco, Cephas, and Orion. And then our population numbers, 11,123, 879, 3518, 1563, and then 2917. And so the total population here comes out to be 20,000, right? And then these 20,000 are represented to have 25 representatives. And so that would mean we take our 20,000 and we divide that by 25. And we get our number, which is 800. So about like 800 people per every representative is what that means, right? And so now we're going to figure out what would be the quotient. And so to get that number, we just take the population of that state. So in this case, the 11,123 divided by the divisor, and we get 13.904, right? And we would do the same thing for each of the other ones in our list. And so we'll write down what the quotient is for each one of those. And then we get 3.646, right? So we get that, and then the next number we want is what is called the standard quota. And so basically here, all we're going to do is we're going to truncate our numbers. And so that means we just take the whole number part. So that would be 13 for this one, 1 for here, 4 here, 1 here, and 3 here. And if we add that up, we get 13, 14, 18, 19. We get 22. And if we look at this number, we are 3 short of the 25. So we got 3 more representatives. We have to figure out who gets them, right? And the way you decide who gets the extra ones is by now looking at the decimal part of our numbers, right? So we got 3 more to award. So we want the 3 highest decimal parts, right? So the highest one is the 0.954, so they're going to get 1. The next highest is the 0.904, so they get another 1. And then after that is the 0.646. So they will pick up another 1. And so now we get to our final tally and the number of reps. And so Aphis gets 14, Libra 1, Draco has 4, Cephas has 2, and Orion would have 4. And if we add that up now, we have 14, 15, 19. We now get 25. So all they have been spoken for. Right? So we have them all awarded by this method. Right? We found out when we originally did this, however, we were a few members short. And so then we had to start looking at those decimal parts of our numbers to figure out who gets an additional member, right? Well, the next then is called the Jefferson Plan. So the Jefferson Plan tries to get rid of that step we had to go through, and here we modifies the standard divisor. Right? And so here, in order to do this, for my example, so in order to do this, the standard divisor needs to be less. Less than the 800. Nope. And let's make that a little better here. Let's be less than that 800. Right? All right, so now it's a matter of sort of taking a shot as to what you think the new number might be. We know it's got to be less than 800. And so let's go here. My new divisor, I'm going to say, I'm going to go for 760, right? And we're going to see what that does for us, right? And so again, we have in terms of our states, we had Aphis, Libra, Draco, Cephas, and Orion. Right? And our population numbers, 1, 1, 1, 2, 3, 879, 3, 5, 1, 8, 1, 5, 6, 3, and 29, 17. Right? And so now we get in terms of our new quotient number. So we're going to divide. Okay. So now it's going to be the 11,123 divided by our new number, which is 760. And so this gives me 14.636, 1.157, 4.629, 2.057, and 3.838. And again, we write down our standard quota. And now we have 14, 1, 4, 2, and 3. And so now we got 15, 19. We're now up to 24, but we are still short by 1. Right? So that means we need to try this again. Right? So let's try a new divisor. So we now have to make it even smaller because we're not quite there yet. So let's go now for 740. And so again, we have in terms of our states, Kleber, Draco, Cephas, and Orion. Right? And so we had 1, 1, 1, 2, 3, 879, 3, 5, 1, 8, 1563, and 2917. Right? And again, we're going to get our quotient. So now we're going to have, do the first one out. And so now this one gives me 15.031. And then the other numbers, 1.188, 4.754, 2.112, and 3.942. And then our standard quota. And so we have 15, 1, 4, 2, and 3. And so this now gives us 25. So we have accounted for all of our representatives. Right? Right? So everybody is accounted for now. Right? So our new modified divisor that makes this work ended up being 740. So we went from 800 down to 740 to get this. Right? All right. So in terms of some of the rules, first rule is the quota rule. The number of representatives apportion to a state is the standard quota or one more than the standard quota. And we saw that with our first examples we did. We got the standard quota, and then we gave a few of the states one more member. Okay? Next term then is the average constituency. Is given by the population of the state. Population of the state divided by the state, divided by, not by the state, population of, there we go. So the population of the state divided by the number of representatives. And then the next term is the absolute unfairness of apportionment, of an apportionment. Is given by the average constituency of A minus the average constituency of B. Okay. Okay. All right. So other methods of doing this then is the Huntington Hill apportionment method. Right. And so here you get the Huntington Hill number. And the way you get that is this. It's the population of the state squared divided by the number of representatives they have times the number of representatives plus 1. Okay? So P sub A is the population of state A. Right? And then A is the current number of representatives. Right? And let's go through an example of that. Okay? So we'll go through this example of how that works. And so we now have here, in terms of the beach, the number of lifeguards and the number of rescues. Okay. So we have Mellon, we have Donovan, and we have Ferris. Okay. So lifeguards, we have 37, 51, 24. Rescues, 1227, 1473, and 889. Okay. So we can now calculate out that Huntington Hill number. Right? So for the first beach, Mellon, that's going to be the 1227 squared over 37 times 37 plus 1. And that'll give you basically 1071. For Donovan, we have 1473 squared over 51 times 51 plus 1. And that'll give us 818. And then lastly, for Ferris, we would have 889 squared over 24 plus 1. And that comes out to be 1317. Right? So Ferris has the bigger number. Has the largest Huntington Hill number. So they should get the new lifeguard. Okay. So they should get the new person. Should go to them. Right? Right. So you have in terms of apportionment in various methods, and there are a few others in the book you can look at that they talk about, but those are the main ones. Right? The next thing then, part of this chapter, goes on to voting. So in terms of voting, so you could get in terms of first plurality, right? And that is basically the person with the most votes wins. So if you have only 2 people running, then it will be the person who has the majority. Okay. Okay. If you have 3 people or more running, you could have somebody who wins the election, but does not necessarily have a majority. Okay. So if you have more than 2, they won't necessarily have to have a majority to win. Right. So let's look at an example how this might work. And so let's say now we have, in terms of various measures, got a measure A, measure B, measure C. Okay. And then we have in terms of rankings. And so we had 1, 3, 3, 3, 1, 2, and then 2, 2, 1. And then in terms of number of votes, we had 15, 12, and 9. Okay. So what this chart tells me then is that measure A got 15 first place votes. Measure B, measure B got 12 first place votes, and measure C got 9 first place votes. So if this was done in terms of a plurality voting system, then the winner here would be measure A wins. In a plurality vote, it got the most first place votes. It is the winner. Okay? But it did not receive the majority of the votes, because after all, we got that there were 15. We had 36 votes altogether here. Okay. And so measure A only got 41.6%. This one is 33.3. And then this one would be 25%, right? So measure A wins, but it did not receive a majority. Right? Right. Well, what would happen if we changed our voting system here? And what if the election was held based on preferences or rankings? Okay. Okay. So if we did it in this system, we would then say, okay, we do it basically in terms of a point system. So now it would be based on points. And so being first is worth 3 points. Being second is 2 points. And then being third is worth 1 point. And then we want to see, well, how did these stack up? Right? And so let's go through this now for our measures and see now who wins under this system. So measure A. Measure A. So in terms of first place votes, it had 15. So it's going to be 15 times 3. Okay. And measure A had no seconds. So 0 times 2. And then it had 12 and 9, so it had 21 third place votes. So 21 times 1. And so this is going to give us 45. This is going to be 0. This is going to be 21. Measure A gets to 66. Let's now do measure B. Now, measure B had 12 first place votes. So 12 times 1. It had 9 second place votes. Or actually 12 times 3. Sorry, that should be 3. So 9 times 2. And then it had 15 third place votes. So 15 times 1. So this is going to give us 36. This is going to be 18. And this is going to be 15. And that gives us a total of 69. And now we go to measure C and see how it did. And so measure C had 9 first place votes. So this is going to be 9 times 3. It had 27 second place votes. So 27 times 2. It had no third place. So this is going to be 27. This is going to be 54. This will be 0. This gives it a grand total of 81. So based on this method, measure C is the winner. And this method is the Borda count method. Right. So we have in terms of that method. All right. So the last thing I'm going to talk about then in this video is going to be what is called the weighted voting system. And I'm going to talk about this by also doing an example as to how this works. So we get something like this. All right. 300, 250, 200, 150. Right. So we get something like this. So we got 626. This first number here tells you the number needed to win. That's how many votes are needed to win, right? The next numbers are how many votes each group controls. So basically we got then that A has 350. B has 300. C has 250. D has 200. And then E has 150, right? That's how many votes each one of those blocks controls, right? So now we want to know is how do we get to that magic number of 626? So we're going to build a chart based on those numbers and see what do we get. So we want to know in terms of first the winning coalition. And then we want to know the number of votes they would have, right? So a winning coalition, so for example, would be A and B. A and B together would be 650, which would be enough to win, right? So we go through and we list all of the possible combinations that would beat that number. And so this is going to be 900. This is going to be 850. This is 800. Okay. And so there's going to be a few here. ACD, ACE, ADE, BCD, BCE, and let's put down some more of these numbers here. Let's see, this is also 800. ACE is 750. 700. Another 750. And another 700. Right? Let's see, we got BDE. A, B, C, D, A, B, C, E, A, B, D, E. Right. Let's get down that block of numbers. So this is 650. This was 1100. This is 1050. And this is 1000. And just a few more to go here. ACDE, BCDE, and then lastly A, B, C, D, E. And so these last few numbers are 950, 900, and the last one here is 1250. Right? So we have down all the possible winning coalitions and the number of votes that they would contain. So now what we want to know in regards to this is what are the critical voters? So basically what that is, if you think in terms of my first coalition, A and B coming together, the critical voter would be if one of them decided not to vote, would that person then lose? And in this case, if either A or B changed their mind, there would not be that number needed to win. Okay? So then in this one, it would be A and B. Okay. So in my next one, my coalition being A, B, and C. C is not important because A and B by themselves would have enough to carry the vote for the winner. Okay, so that's why C is not listed. Right? And then same thing here. A and B are important. D is not. Okay? And then here A and B. Right? So we go through each of these and we figure out in terms of the numbers. So this one is A, C, and D. This one is A, C, E. This one is A, D, E. And let's see, then we got B, C, D, B, C, E, B, D, E. And the next ones, none of those are critical, because there would still be enough to be above that number needed. And then here we get A, here we get B, and lastly down here we get none. Right? Right. So we have all that down. So now we're going to do some calculations with this, and we're going to get what is called the Banzhaf Power Index. So we're going to calculate this, the Banzhaf Power Index. And so here it's going to be, that is given by the number of times a voter is critical, divided by the number of times any voter is critical. So we want to get a few numbers here. So let's first figure out that bottom number. Any voter critical. Let's get that number. Any voter critical. So we go through and we barely count up how many the letters altogether. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 27, we have 28 there. Okay. Okay. Now we want to figure out in terms of each of my, so we're going to figure out the number for how many times A appears in that list, how many times the B appear, and then C, D, and E. So we're going to figure out and go look at that and figure out how many times each one of these letters appear. So if I go back up here and I read through this, you'll find out that A occurs 8 times. So A is going to be 8. You'll find out that B is also 8. And then C, D, and E each appear 4 times. Right? So now we can figure out that number, and so we would have the power index number for A is going to be 8 out of 28, and we're going to round this to be 0.286. The number for B is also 8 out of 28, and that will also be 0.286. The number for C is going to be 4 out of 28, and that we're going to say is going to be 1.143, and then the numbers for D and E will be the same, 0.143, and lastly this will also be 4 out of 28, and this will also give us 0.143. So we have calculated the index for each of our things, right? And that will conclude this video.